I kindly ask to Beatrice to start the registration in a few seconds. I think that you already have my screen shared, and I also kindly ask Beatrice or Martino or Luca to grant newcomers to access.
Yes, sure.
Okay, so thanks. Thanks for joining. This is the third webinar of a series of webinars organized within EDIAQI project, focused on the interoperability of dynamic data, and with a special focus on the standard SensorThings API published some years ago by the Open Geospatial Consortium. So today, as for the previous two sessions, we will split the webinar into parts. In part one, we will start with a brief introduction, where we will have just a brief description of the overall aim and goals of today's webinars. And in particular, we will start seeing some examples, some web implementations related to visualization of air quality data. In this case, we will see examples running on the web for providing near real-time air quality information for outdoor air quality. Then, after this brief introduction, we will jump into the first group of examples dedicated to software libraries available as open source code for implementing a web-based application for accessing dynamic data from SensorThings endpoints. And this first group will be dedicated to JavaScript libraries. Before the coffee break, we would like to stimulate some discussion about storytelling, in particular talking of the main content of the main purpose of the EDIAQI project, that is indoor air quality, how to deal with indoor air quality data, how to present this data in a more in a useful and understandable way. At 10:30 more or less, we will have a half an hour coffee break, and after the coffee break, we would like to have a brief recap of inputs collected from participants about alternatives and options related to the visualization of indoor air quality data. Then at 11:15 more or less, we will have the second group of examples of implementation for accessing dynamic data available from SensorThings APIs. In this case, we will have an example implemented using Python language, and adding functionalities to a GIS desktop open source software. At noon, we will recap with some conclusions, and we will present the topic of the next and final webinar that will be organized at the end of October. We will leave the floor at the end of the conclusions for some questions and answers from the audience. Today, apart from me, there will be Luca from Deda Next presenting the JavaScript libraries examples. Then we will leave the floor to Marcello Verona from the Lisbon Council for stimulating all of us around data visualization and data storytelling. And then Beatrice, we will talk about the Python-based examples in the second part of the webinar. So to start, let me just remind what we already presented in the previous two sessions. On June the 21st, we introduced the SensorThings API, that is a recent standard, open standard published by the Open Geospatial Consortium, and we focused on which kind of requests SensorThings API allows, so how it is possible to interact with RESTful services through multi-parameters requests that can be obtained, that can be asked for to get dynamic data from SensorThings endpoints. We also, in the first session, we also had a first look at the Frost server, that is an open source solution implemented by the Fraunhofer Institute, offering capabilities and functionalities for implementing server side what the standard SensorThings is for. And we also introduced some evolution for the SensorThings APIs, like the STI Plus, that is a sort of plugin of the standard itself. We concluded this first session looking at what the European Inspire Directive is asking for when talking about dynamic data, in particular for monitoring facilities and for environmental dynamic data like air quality. In the second session, organized on July 21st, we invited Dr. Hilke van der Schaaf from the Fraunhofer Institute. That is, Dr. Hilke van der Schaaf is the project coordinator of Frost open source project. He explained reasons of implementing such open source project, its characteristics, and also further evolution that have been recently undertaken. Together with Martina and Beatrice, we then had a look on practical examples of how to deploy Frost on Tomcat or on Docker. And then we had some examples of how to ingest data, looking at what already done in a previous project in the case of Ferrara municipality in Italy for dynamic data about weather, traffic, and also outdoor air quality. All these materials, so the materials, slides, and also videos recorded during these first sessions are available in the web page of the EDIAQI site at the link at the URL that you find here in the bottom right corner of these slides, or through the QR code. So feel free to access and have a look at them. So today we will see examples of data visualization, basically. So examples of implementation that can consider also SensorThings endpoints to present dynamic data about not only air quality, but different domains. Of course, the focus and the goal of the EDIAQI project is on indoor air quality, but the same considerations can be applied to other types of data themes and domain. So what is data visualization? Here I put a quite famous example of one of the probably first examples of data visualizations. In 1869, a civil engineer from France called Charles Minard created this quite famous flow map with data about the losses of Napoleon's troops during the Russian campaign some years before, so in 1812, if I remember correctly. And in this diagram, on the left, we have the size of Napoleon army at the departure from the border between Poland and Russia. And the flow displayed basically 6 different types of data in 2 dimensions. The number of troops during the time, the distance traveled, the temperature, also the latitude and longitude of events, the direction of travel, and also the location of specific dates. And this type of this typology of displaying data was then later called Sankey diagram, even though the author, Mr. Matthew Sankey, used it some years later and only for representing energy flows. So data viz can be summarized with this definition taken simply by Wikipedia page. So is the practice of designing and creating graphic or visual representations that are aimed to communicate data and information in an easy way and in a way that is understandable for the majority of people. And basically, this means the involvement of different types of formats of format representation, including tables, charts, maps, graphs, diagrams, figures, matrices, and so on. Many times, all these types of representation formats are combined in a dashboard. So let's have a look very, very fast at some examples already available about outdoor air quality, starting from this first one, that is the European Environmental Agency Air Quality Index portal, that is presented through a map, but data about each single monitoring stations are then displayed to the user through different types of diagrams, like this pie chart, but also with stripes, with mini stripes displaying the trend of different parameters along the last days. Of course, there is a legend explaining the meaning of colors that are corresponding to different ranges applied to each parameter. A second example is from the US. The EPA agency is not presenting any map representation. The user is just asked to select the typology of pollutant, the temporal period, so the year, the city, so the geographical area, and then a series of diagrams like this one, or this one, or again, the following one are presented. And in this case, also with the possibility to download these data directly from the portal. Another example is this dashboard from Bristol, embedded into the Open Data portal of Bristol City. And here we don't have, again, a geographical representation, a map, but vice versa, we have a list of speedometers, one for each monitoring station, displaying in a very effective way the situation for each station, using an air quality index displayed yes, with this diagram with this speedometer. A map is indeed existing in the bottom part of the dashboard for identifying each single location, each single station, and of course data are also presented in tabular way. So different representation formats are available in the air quality data dashboard of the Open Data Bristol portal. Another example, always about outdoor air quality, is this collaborative project called World Air Pollution Info at this URL. You can also access it through the QR code on the right top corner. In this case, again, we have similar data. So the information is sourced by the same sources used also by the European Environmental Agency. So we have official authoritative data coming from official monitoring stations spread not only all over Europe but worldwide. But in this case, by clicking or by mouse over on each specific station, we have in a very effective way the last situation, so the presentation of the air quality index for that specific location, and also this sort of matrix that is a sort of a calendar showing in an effective way the trend in the last month with columns that are representing the different days of the month. Another example is this portal that is more focused on citizen science sourced data, and here the representation offers the possibility to display different types of layers, different types of sources, considering and filtering, applying different types of filters, and the data are presented through these pop-ups appearing when clicking on a specific station by showing the air quality index and explaining also the meaning of values. Then we have this example that was one of the first implementation based on SensorThings as a backend endpoint from Calgary in Canada. And also in this case, we have a map component. We have a sort of calendar where it is possible to filter, so to change the temporal reference. So it is possible to update in a dynamic way the day for displaying data on the map, but also on the diagrams on the left. Data are also presented like dots like this. So we have a trend for each specific station presented in this way, and it is also possible to compare different stations among them, like in this example. Then a final example is what has been implemented last year in the air brake project in Ferrara, Italy, where data are presented with a dynamic and interactive map that is tightly coupled with a chart on the left. It is possible to filter and select one or more stations, but there are also another JavaScript widget included in this web page that present the user in a simple way the specific situation for each parameter that is used for calculating the index. So in this case, PM2.5, PM10, NO2, ozone, and CO. And also this that is the entry page that is showing the situation at a specific time with the floating particles that are again another example of JavaScript open source libraries connected to a server that is exposing that is providing the data at that specific time. And this is basically summarized. So in the case of the Airbrake project website, this is summarized in this slide. So in this case, the user interface is fed by data that are streamed by a web service that is not directly the SensorThings endpoint, but another type of standard web service provided by the municipality of Ferrara. But today we will focus on examples of web and desktop client connecting to OGC SensorThings APIs. So I would leave the floor now to my colleague Luca that will present the first set of examples of web-based clients, in this case with implementations developed by using JavaScript libraries. So I can stop sharing my screen and leave the floor to you, Luca.
Wait a second, because there was a question, a hand.
Okay. Thanks. Sorry.
Hi, good morning. Thank you very much, Giorgio. I saw your slide on visualizations, and we have a task, and we're in good contact with this. Are we focusing also to Lisbon Council a question? It refers to how to do visualizations when you do marketing and you have business clients. So in our project, that would mean that the client is actually the person who bought the indoor sensor system, or is it the visualization? Do we want to target the people who are controlling the whole house, or the office or the school owners, or should it be for the people who are in the classroom, in the office room? Because these are two different types of clients. It's just how do you see it? Which one would be better as a stakeholder for this type of visualizations?
I think that you touched the point. Then I would like also to leave the floor to Marcello to answer to your question. I think that you touched the point because, of course, depending on the type of target that you are looking at, so the category of user or the categories of users that we have in mind, different types of approaches and different types of representations can be implemented and should be implemented. So this is very strictly dependent on the categories of users. The majority of them, like what you mentioned, people within classrooms or within offices may ignore the meaning of unit of measures, thresholds, or even specific values of parameters, That's why, for instance, in the case of Ferrari, in the example that I mentioned, we were asked by citizens, also by civil activists involved in local environmental associations, to avoid possibly any numbers, values, unit of measures and thresholds, because the majority of people in this case are not aware about the meaning of nanograms per cube meters or legal national thresholds defined by law applied for daily average values. So it is important, not only in the EDIAQI project, but in general, to have a clear understanding of the categories of users, and in some way be driven by them for designing properly the user interface, the functionalities, the interaction between the interface and the user.
I think it's a good direction if we concentrate on facility managers. This is also maybe then this marketing and business approach as you presented now. And yeah, I'm happy that I saw this slide, because that would mean that the work that we've done already, where we focus on the facility manager, it's easier, because a lot of people don't want to show how bad air they actually have in their office space for legal reasons. So also the tip that you gave on us end of July when we had the workshops was really good, to remove the units of measure. But yeah, if we keep the focus on facility manager, it's a different story. If we want to now focus on children, their parents, seeing the red values in the classrooms, we might get into legal trouble, and we might have problems setting up sensors in the EDIAQI sample, because people don't want to get bad comments from parents and don't want to have legal cases popping up. But
yeah, I don't know if Marcello wants to add some thoughts, some consideration on that. Your microphone is muted, Marcello.
I said no. I fully agree with you about the consideration about the right visualization with the right target. This is and you are more skilled than me in this area about this. I fully agree with the approach.
Okay, thanks, Marcello. So thanks also, Lina, for the question, for the comments. I leave the floor to Luca. So the screen is yours. Yeah.
Thank you. Good morning, everybody. Can you hear me well?
Yep.
Okay, great. So I'll just share my screen. And this is the screen I want to share, and turn off my face because it's not needed. So do you see my screen?
Yes. Yes.
Okay, great. Okay, so the topic I will be presenting, as per Giorgio mentioned, is the one of web dashboards based on SDA endpoints, so based on data stored following the SensorThings API standard. And what I will show you are examples of available solutions based on basically JavaScript, open source JavaScript libraries that can be used to create dashboards, to navigate and explore the data that you might have collected following the SensorThings API standard. So to begin, let's have a quick recap of what it means to have data stored in a SensorThings API compliant infrastructure. And for sure, what it is, the SensorThings API standard. It's a standard. It's supported and published by the Open Geospatial Consortium, and it is meant to have a way, a common way, a standard way, to expose data about sensors. Of course, there has been in the past decade many sensors have been built and put into use. They all have their own way of storing data and of communicating it. They have their own proprietary APIs, and that limits the way to connect to them all. If you have if you have more than one type of sensors and you want to gather data on your central infrastructure, then from all of them, then you have to think of a way of connecting to different types of endpoint. While if we are able to spread the use of such a standard, and if that standard can be implemented at the level of single sensors, then the users would benefit from the fact that they just have to think about one way to connect to all different types of sensors, the standard one. And SensorThings API is a standard covering exactly this aspect, the communication of measurements from the sensors to the users. And there's also a second topic domain where this standard provides regulations, which is the tasking activities of sensors, which will not be part of this workshop, but it's useful to mention it. The STA, SensorThings API standard, prescribes how to send instructions to sensors. Think of sensors that can be manipulated from remotely, like a camera taking a video of an area, maybe to identify people or cyclists or cars, bikes that are passing by. It's a sensor, and you could need to command it to move from one direction to the other, or to zoom in or out. That would be a tasking activity, and that is also subject to standardization. So that is the SensorThings API standard and the reasons for having such a standard. The standard basically, and I'm focusing now on the standard about providing data from sensors to user. It's made of two elements. It describes how to organize the information. So it provides a data model, which is exactly the one I'm showing here. We had time to discuss it. It's based on 3, 6, 9, well, actually 8 entities. And it's really not, the entities are quite easy to understand. It's not a complicated schema, and it's rather effective. Basically, I'm not going to describe it in detail, but you can see that there is a place, a table, let's say a table in a DB, where you have to describe the properties of the sensor taking the measurement, another table where you have to describe the properties of the element of the physical world that hosts the sensor. Like if you have a sensor measuring temperature in a box placed in a measuring station along the street, the station would be the thing. And then you have a table, of course, to store the observation, so time and value, etc., etc. A table to store the location of the sensor, etc., etc. So the standard prescribes, the first thing it prescribes is how to organize the information. Then it also prescribes how a service, a protocol should be built to allow users to access to data in both in reading and in writing data, and what kind of query, what kind of interrogations can be done to the data, and with which syntax. So it also describes command to ways and syntax to access to the data. Those are the two pillars of this standard for what concerns the part of data communication from sensors to users. Then, of course, the standard is one thing, is a document describing how things should be done. Then if you want to actually make use of it in the real world and start collecting data, you have to implement it. And luckily, that standard has already been implemented by different operators, by different companies or organizations. And we chose one that is developed by the Fraunhofer Institute in Germany, that we find robust and with lots of use cases already implemented, so that prove its robustness. This implementation is called FROST, which is an acronym for well, of course, SensorThings API, and well, I don't remember. Anyway, it's an acronym for server implementation for SensorThings API standard. You can find all the information on the very well documented website. We have already in the previous webinars described how to install it, configure it, and what it provides. It basically provides a schema on a Postgres database. So that implements the schema, the data model that I was showing previously, and then it provides two protocols to communicate with the outside world: one HTTP protocol to read and write, and one MQTT protocol. Then, once you have this implementation in place, as I was saying, you basically the way you interact with it it's through endpoints, and let's focus now on the HTTP endpoint. That is a place, an address, an URL meant basically for machine use. So meant for the quick and exchange of data and of big volumes of data on, well, actually any volumes of data from machine to machine. So from the Frost server to any other server or client needing to access to data. And that means also, that could mean also a web page. If your aim is to show the data, or even to process and show some derived computation from the data, that can be done via quite easily through a web page by using the proper support from proper JavaScript libraries, and that's the topic of this presentation today. Yes, just one last slide of recap. There are, as I was saying, there's already many endpoints, Frost endpoints available, or actually STA endpoints available, and by chance those examples are all all have a Frost implementation of the STA standard behind, but it's not necessary. That's not the point. The point is that they are all endpoints, all endpoints exposing data following the STA standard. And as you can see, you can have access to data about the first one and top left, access to data about water levels and water pollutants in France. Then the second one, top right, you have access to the statistics and demographic for Germany, COVID data again for Germany. Then you have the third one, data about air quality, bike transit and traffic in the municipality of Ferrara. And then the fourth one, they are just for example, data about air quality covering the whole of Europe from the European Environmental Agency, collected by Fraunhofer Institute. So you can, if you go there, of course, they are meant to for machine-to-machine communication, but you can access them just by copy pasting the URL. I suggest using Firefox, because the answer that the URL will provide is a file structured in JSON format, and Firefox is able to show the output of a JSON file in a way that's readable also for a human being. So you can you can try it, but they are meant, of course, for machine use. So now that we know this, how to go from a STA endpoint to a web dashboard, there's many ways. Luckily, also on the domain of JavaScript libraries related to STA, there's already been done a great work. So first solution that we scouted, we were, of course, as data group, interested in developing such web dashboards. So we did a little bit of research on our own, and that's the outcome that we got. First solution is so-called STAM, STAM, by DataCove, which is a JavaScript library for showing the things, features of interest of SensorThings servers using leaflet and or actually open layers as mapping libraries. So that means that you have a web page and you either choose leaflet library or open layers libraries to show data on a map. They are mapping, JavaScript mapping libraries. They are not STA libraries. And a STAM JavaScript library to connect to a STA endpoint. So you have maps and plots, and the plots are based on an open source JavaScript library for plotting that's called Plotly. So let's have a look at them. Actually, I will also show them in real. What you can do is start from the GitLab page, which is the one you could reach by using this QR code, and also looking at some examples that will give you an immediate idea of what's possible with it. So basically, this is the first example, is the simplest of it. We have a map that shows the location of sensors. So this map is connected to an STA endpoint, and it shows the locations of the sensor stored in that endpoint, and for each actually of the things. So the things of the real world that hosts the sensor, and for each thing you have a list of information based on the model below or on the model behind. So they are telling you what kind of thing is measured here, and this is it's a catalog of plants and flowers. So you will see information about plants and flowers here, and no other type of plots. So this is the simple one. Then there's another one that again provides a map with location of things, then provides the textual information about what's the property, what are the properties that are measured, and then there's a plot of the values of any measurements along time. And then there's even a more complex and advanced example where, again, the base is the same. You have a map and you have the location of things, and then selecting one, you have the basic information. You have a list of things that are measured at the station, and if you click on one of those quantities, physical quantities, you have the plot, and you can choose to see data just for the past 24 hours or for the past week or for the past month, etc. So you can really navigate through data. Well, I promised you that we are going to have a live demo. So this is the GitHub page for STAM. You have the link in the presentation. It's the first QR code. So there's a little documentation and, of course, all the code. You're welcome to contribute. This is the first example with no plot. It's plotting the Natosfera data, and it has some features. It's based all the three examples are using STAM as the STA library. So they all have this feature of clustering things that could be nicer, but again, it's an open source library, so you can go and change it if you don't like it. And so when you actually arrive to an area where there's sensors, single sensors, you click on one and you see the information about the plants that were identified in that location. And in some cases, you can also view an image. Well, in this case, no, maybe this one. but it's not really the point. It should work. It's not my fault. If it doesn't work, I didn't do it. But that can be possible. Then this is the second example. Again, you see it's the same library because it has the same, you can recognize the same features, the way of handling the clustering of stations, of things. This just means that here there's 31 stations and they are too crowded to be shown as single pins. But if you zoom, then there's enough space now to show the 31 pins. You choose one, and here you just have this physical quantity measured, so PM10. You click on it, and in this case, for this station, you don't have data for a reason, or probably you don't have data at all. So let's just go to Germany, since this thing was done in Germany, and they probably have more data there. In this case, I assure you there's data because I took a screenshot. But anyway, that's not the point here. You see. So in this case, you also have access to data. You can zoom in, zoom out, move from left to right. I think so. And lastly, this is the most advanced example. This, I have to say, is based on SDAM library, but it has been further developed. This example here, the library that's used in this example here, has been further developed in a closed and proprietary library from Fraunhofer. So this is just this. You won't be able to start from this situation. But this is a good example of what you can develop on your own, starting from STAM. So the difference here, well, apart from the fact that there's no data here. So again, let's go to Germany. The difference here is that, well, you still have metadata, let's say, information about the thing, about the properties of the thing I just selected. You can choose, okay, you can choose the single, the physical observables that you're interested in, and that was already available also in the other example. But now the plot is a little bit more interactive in the sense that you can choose the different scale. And I think you can also download data somehow. Let's see if this is the case. No, maybe not. Anyway, you can see that there's room for improvement and you can adapt it to your own needs. This is a feature that personally I like a lot. It still remains a tool that's not meant for scientists, let's say for people that actually have to do something with those numbers. It's still pretty just a visual tool, but it's nice that you can navigate different scales, and probably you can also exactly move left or right in time. Okay, so back to the presentation. This is it. Oops, sorry. This is the second solution. It's an SDK from SensorUp, the same Canadian company that Pier Giorgio mentioned in its previous presentation. In this case, they are not providing an open JavaScript library for connecting to SDA. There is a library they are developing. You can link to their library, but it's not open source in the sense that you cannot contribute to expand it. You can use whatever they have now. You can, of course, take it and then expand it on your own, or maybe you have to check the license for that. So probably no, but you can use what they have. And for what concerns the handling of maps, they are using Leaflet. So here the support is just for Leaflet and not for open layers. They are the two main competitors in providing support, JavaScript support to maps. So I just wanted to point out that here, if you choose for this library for the SensorUp one, then you have to stick to Leaflet as a mapping library. And then for charts, they use HiCharts, which is not, again, an open source mapping library. It's a library, a JavaScript library that handles charts, of course, charts and plots, but it's not open. You can use a basic version of it for free, but then you have to pay if you want to use the advanced components. So be aware of this if you choose this path. So this option is good. You can see, we'll see they have very nice solutions and examples already available that you can copy and reuse. So it's a good solution if you are okay with what's already available, but it's not a good solution if you want to start from here and expand it. So at this link here, you will see this page here, which is the example page of the Developer Center of SensorUp. You will have access to tutorials with code on how to show on a map data from an SDA endpoint in a nice and interesting way. And then there's a second tutorial about graphs and gauges that shows you that tells you how to use their library to show data in plots and gauges. But there's more still, since we are here. You also have a nice documentation about the SensorThings API itself. This is not about the graphic component, it's about the API. But since SensorUp is one of the companies that were behind the work, the defining the standard, they are particularly keen on it, and they are providing a lot of nice documentation. They are describing all the different entities, so it's a very useful. They're providing an example on how to interrogate the APIs, and it's a very useful resource. Going back here, I already partially showed to you. You can have examples related on how to show, so tutorials and walkthroughs with code on how to style and show SensorThings data on a map. Same thing on charts. And then the most useful is this last part, a sandbox, where we have example of different widgets, plots, charts, maps, with the code that you can change in line and see what happens. They are connected to SensorUp endpoints, SDA endpoints, so you will see live real data. I can quickly show you this also. So this is the page about mapping. You have the description, but also examples, explanation related to the code, to the JavaScript code. Same things about plots. So description, step-by-step description, and also description of how to do it in code. And then this is the sandbox. You see there's plenty of examples of different widgets with the code and how to implement it. For example, I don't know, I didn't check all of them, but they seem to me quite nice. This is not work. No, it works. There was also a histogram, basic bar chart, and an advanced one. This one. Yes. So they are also rather advanced, and they're all based on SDA data, and they are all open. You can see they're all open to reuse as is. They rely on this JavaScript library. That is the one that SensorUp is developing, and as far as I know, it's not open, but you can use it as is. And then, yes, third solution is basically do it yourself with the tools that I've already been showing you in the previous solution. So for mapping, you can rely on leaflet or open layers. For plots, you can rely on Plotly or Chart.js. All 4 of them are open source library. And for the SDA component, that's the do-it-yourself part. It's not that complicated, because the complicated part in the dashboards that we have seen are basically handling mapping and plots. Actually, and the SDA components boils down to calling the endpoint, receiving a JSON with the output of the data you are interested in, and then extracting from this JSON the numbers, the values, the information that you want to show either on map or on plots. So it's doable by yourself if you can rely on already existing libraries for these other 2 activities, mappings and plots. As to prove you that it's possible, I will quickly show you 2 examples that we developed on our own in the project Airbrake. And if we have some residual time, I'm not sure, we will also see elements of code. First, there are basically 2 examples. One, we called it SDA Monitor. It's a web page that is used to check. It is connected to one endpoint, the one of the municipality of Ferrara, and it checks each of the data streams of that endpoint. So each of the historical series of data related to one specific measurements of one specific station, to see if they are in delay, if there's some problem related to the provision of data. So it's meant as a way to quickly check if we are missing some data, if some of the station is not properly sending data with the frequency that we expect. We will see it for real in a moment. And then the second one, it's called SDA Explore. We called it that way, and it's basically a dashboard very similar to the example that we have seen up to now. It shows the location of the things on a map and allows you to explore them. It gives you, the difference is that it gives you, when you click on a station, it gives you a view of all the physical quantities that are measured at that station, but also it provides you immediately with the last value available, timestamp and value and units of measure. It tells you how much in delay it is with the current time, and then allows you to have a plot showing the data, and also to download the data via in a CSV file immediately. So we needed something that gave as soon as possible as much information as possible to the user. So let's have a quick view of those 2 examples. So this is the monitor. You have the server in the municipality of Ferrara handles 5 types of sources related to air quality data. The one from a sensor installed specifically for the project, and then station from the official measuring agency, which are regional. So there's the 3 regions that are the region where Ferrara is in, and the other 2 regions that are close by to Ferrara territory. And then there's another unofficial set of stations from the same regional environmental agency where Ferrara is. Here you can see with a color code that the situation is not very well. We have been experiencing recently big delays from the official providers, while the situation is rather good for the local station. Here you have, for the local station, the project stations, you have the list of the names of the station and the information about which one are how many data streams are providing, and if we are missing some of them, or if they are in delay, then you can click on one of the stations, and then you have the detailed view of all the observable of that station, what's the first measurement available and the last measurement available, and if there is a delay, you can see there is no big delay. And then again, if a delay was present, no, yeah, that's where you have to click here. Then you can click again on the station here, and you will have a even more detailed view on for each observable here of each station about the percentage of measurements available in the last 6 hours, 12 hours, and 24 hours to see if there was any single missing value for this type of measurement, which is supposed to provide a value every hour. So it's a there's like 3 levels of details, and it's meant to provide a very quick impression on how the situation is going. Then for the monitor, these are all station available at the in the endpoint of the municipality of Ferrara. There's for different reasons we need access to data that's well, I've mentioned we have access to the measurements of the weather station and the air quality station for the region where Ferrara is in, which is this area here, but also for the 2 neighboring other regions that are here. But let's zoom on Ferrara, where the most activity is, and see once we have, well, it's still under development, so you see a tree to represent the single station, while it's actually not related to trees, but you will pardon me. How can I do it? This, like this. But no, this is not, we are not in good shape here. See, the delay is big. Actually, what I wanted to show you is this one, which is better. And this is basically the content of the screenshot. I just wanted to show you the plot. Here is, you can see we used Plotly, the same as the STAM library. It's still raw. We want to add the buttons about being able that will allow us to show the data from the past week or the past month. This is just the past 24 hours, but still we already have a plot, and also the download part, it works. So I should have downloaded exactly the measurements about, see, it's very raw. It's not yet completed. This shouldn't be X and Y. It should describe the content of the 2 columns, but it's still under development. The point is that we have 24 values related to the last 24 measurements for CO in that location. And that's it. I don't remember when I am supposed to stop, but
you are perfect, Luca. Yeah.
Okay, so do I still have like 5 minutes to show the code, or?
Yeah, a little bit less than 5 minutes.
Okay, I'll just show you the fact that the code is open. How can we do this? I think we could just do like this. Well, let's make it a little bit more proper, so you can access to the source of the page. You can see somewhere that the JavaScript library is just plainly this one. I don't know if it will work if I do like this. Yes. So you can have access to the JavaScript, and you can see that basically there's not much action. Of course, I'm using the let me go back here. I'm using Plotly for the plots. I'm using open layers for the maps. So of course I'm pointing to those libraries, and I'm using this own JavaScript library to handle just the interaction with the Frost endpoint, as I was saying. So what you will find here are, let me have a look at the main function, the one that handles the click. Here. Well, it's not actually very easy to read it like here, so let's do it like this. JavaScript. Okay, at least we can read the elements. No, I just wanted to show you the part about open pop-up. yes. So you basically create the URL to interrogate the endpoint. You see there's the URL of the endpoint stored in this variable, and then I really add the by hand by writing the string I add the syntax of the query that I want to ask. I want the list of data stream, and for every data stream I want its observation, and for each observation I just want the time and the value. And this is just to show, the information on the first pop-up. I just want the information about the last phenomenon time available. And for the last phenomenon time available, I want the value and the phenomenon type itself. Then once I have this information, I retrieve it back, and I put this data. I make the call to this URL here. Then I collect the response, and I put it into this variable here. And for each of the elements of the response, I put the phenomenon time in this X variable, very unfortunate choice of name, and the result in this Y variable. And then once I have the data, so this is an array of results, and this is an array of timestamp. Basically the same strings that I was showing before in the CSV that we downloaded. Then you feed them to the Plotly widget, and then the Plotly widget just plots it. So same reasonment for the download CSV, for the function that handles the downloading of the CSV. Again, there's you have to build the call to the endpoint, then you have to retrieve the output from the JSON that's the answer to this call. You put it into two variables, and then you, in this case, you save it to a file as two columns. That's it. So as I was mentioning, depending on what you are aiming at, it's not that complex to develop it yourself. Of course, it's also very wise to leverage on existing open source library if they are already going into the direction that you want. So you really have plenty of options, luckily, for this specific solution. And that's it. If you have question, there will be space for question at the end of the second part of the workshop. So I hope I was clear enough, and I leave the floor to the next presenter.
Thanks, Luca. Yeah, as you already said, if there are any questions or comments, just type them in the chat, and then we will have a discussion at the end of the webinar. I would leave the floor to Marcello.
Thank you, Giorgio. I'm just sharing my screen. Do you see my screen?
Yes.
Perfect. So thank you to Giorgio to invite me to this session. I will have a very small presentation about a question, not an answer. My question is how to tell a story of indoor air quality data.
Marcello?
Hello?
I'm sorry, we can see your the view of the presenter, so not like the full screen.
Sorry.
No problem.
How to? But
I mean, we can still read, so I think that's okay.
I'm probably.
Do you have
using...
like two screens?
Yeah.
So
when you
share, you have
in the wrong screen, probably.
Possibly, yes. Or
when
you share,
no, in the same.
When you share, it asks you which screen you want to share. So maybe you can try to tell when you share that the Teams has to use the other screen.
Okay, probably is the easiest. So I will try with this, and I will stop the sharing, and I will start to share the other screen. Maybe it's better. Okay.
Yes.
Okay, perfect. So we are trying to answer together to a question: how to tell a story about the indoor air quality data. We would like to talk about a technique very used in the last years. We are talking about the data storytelling. What is data storytelling? Data storytelling is an art or a technique of using data with data visualization and a narrative to convey information in a more impactful way and a memorable way. The idea is to transform the raw data in something more easy to be understood. We are some ingredients. Normally, we have our data, we have a context, we have some infographic, we have a story. And this is important because it is more impactful, is more memorable, and can drive more awareness, inform decisions, and inspire some change and action in the people. The idea is to put together these three elements: the data, the visual, and the narrative. If we are good in this alchemy, we will have something new and something interesting, and more normally also more impactful. Normally, how to organize this? First of all, we have to start from the data. We need to understand our bricks, our element to have a good comprehension about what can we do and what is the insight we can give with our data. So we have to bring in relationship, correlation, patterns, but we need to understand, first of all, what we have in terms of interesting data. The second step is to understand also how to visualize, but this can be also in the narrative part. The second step is consider your audience. As Pier Giorgio said, is in the answer to Lina, is very important to understand who is the target, because if we have a group of citizens, will be very different between a community of scientists, of course. And also the tone of voice can be modulated basing on this. And we need the third and fourth steps is about which is the point we would like to reach. Here is we can take the usual steps of the narrative. So we can start from a situation or a problem. We can introduce our problem. We can show a solution applied with our data to the situation. Our data will be the key to explain better the solution and to tell the story. The visualization could include several objects. We can use a chart, graph, maps. We can use plots and animations, infographic, video, and whatever we would like to have. In order to go ahead, I would like to show some example to you. I will start from far away from our topic. I will show a story about Federer. It's a story about sport. It's an interesting story because Federer is an interesting figure in the tennis history, and is a story that probably deserves to be told. So I will go in a navigation with our browser. If you see, but this probably is better if I will share in a different way my screen, because this is too big probably. And just a moment. Okay, I will share here the smaller screen, and so I will start with the, sorry, just a moment. Okay. Do you see my screen?
Yes.
This is a story based on the tennis player Roger Federer, and starts from a line. The key of this story is this line. It's a visualization of the ranking in the world of tennis of Roger Federer, and the second part of the story start with the text. You will have all the time this line in the left side, and when you go down, you see the story, and the line go down with the story. So here they talk about the first period, when his career growth and he start to win everything. We arrive at a period named invincibility. It is a very long period, as you can see in this line. So in this case, in this data visualization, thank you for this approach. You can have a better understanding of a career of an athlete. So you can take a look also to the charts, to the comparison with the other tennis player in the history, some element with in this case a competitor, Nadal, and in the last part, the decline of the story. And here we can see also some play. So we have some pieces of audio. This is not very useful in the data storytelling, but is interesting. Here you can hear an interview. And you have a chart, also a bit complex information. This is a word that storytelling is not easy to be realized, but it's interesting in our case, just for the technique. I would like to skip to another one. This is another story I like, and I showed also to Pier Giorgio some days ago, and it's about Brussels and the population of Brussels. I like this story because it's technically very, very well done, but also because it talks about my city. It's not the city where I born, but the city where I live since 13 years. So the story of this data story is about the migrants. So they start to say the people that the migrants live in 20 major city in the part of 1 of 5, and Brussels is one of them. And Brussels is one of the city with a bigger number of residents from foreign origins, more than 60%, as you can see here. And these people are in the most part not Belgian. And where from these people? Here you have another kind of visualization. And this is probably the core of the data story. Where do the residents live? This is a very well realized system of plotting on the map of the city of the people. So one dot is one person. This is the key of the data visualization. And here you can see the distribution of the Belgian, of the group of the Europe 15, so France, Italy, Spain, and the other organization of the, here is explained how is realized the countries. And here you can see the North Africans, Sub-Saharians, Turkish, South American, and here you have the situation of segregation in Brussels. This data visualization tell a story of segregation. So the people in Brussels lives every community in more or less stay in a precise area. We have not a real melting pot. We have a bit of segregation in neighbors. And here you can find also some interesting information about how the sources, and also for the people and for nerds, you can take a look also to the technologies used. And for example, the Voronoi tree map plugin is used for this kind of visualization. D3, another library very used, very powerful, is used for the more or less every visualization here. And okay. So the third data story I would like to show is data presented by Pier Giorgio to me is very interesting because and it's a bit near to our topics, not exactly our topic, but we are talking about the spread of COVID. Here, this is a story created inside the ArcGIS Story Maps platform. And also here you can take a look to a narrative with maps, with some key numbers, how the virus emerged, use of maps, different type of maps. You can also take a look to, you have some interaction with the maps. Here they talk about the spread from Wuhan and show the international flight, the fatalities. This is very, very based on maps, probably because is ArcGIS the host, but you can see a big use of the maps in this data visualization. So I come back to our presentation. I will. This is a bit. This is just a very quick introduction to the data storytelling and some techniques used in the data storytelling. And now we will arrive to our question: how to tell a story. So in order to do this, we will use a platform to involve you and to gather some input from your side. The idea is to have some element from your knowledge about what is the data, but also the data visualization, and also the kind of text we can use for tell a story starting from the indoor air quality data. In order to do this, we would like to share with you an application for an in direct input. Thank you for Jessica from the last meeting in Dubrovnik for give us this interesting link. And this is the link. Probably, Pier Giorgio, we can add this in the chat of the. I will put in the chat the direct link, or you can use your phone using this QR code in order to get the to reach the tool, the online tool. We are organized the input in 3 categories for now. We have the data, the infographic, and text. You can add some input from and you can decide the category. Well, we can also move it if we need it. So thank you very much. If you have some question.
Thank you. So are we gonna like wait 2 minutes or so until people feel this? Like I think so, and then we can take our break until 11. I will stop the recording now, and then I will make it start again later.
Thank you, Beatrice. I close my my camera.